Hi, welcome to In 5 Minutes. We have seen two conditions for oscillations in general for LC oscillators. In the previous video, you can say this is which type of transistor? You can say P to N. So it is NPN transistor. Emitter is connected over here. Instead of now you can say Z1, Z2 and Z3. You have L1, L2 and C. So what I can say from this, Z1 is nothing but J omega L1, Z2 is nothing but J omega L2 and Z3 is nothing but 1 upon J omega C. Now first I'll write the two conditions for oscillations. What is the first condition? Z1 plus Z2 plus Z3 should be equal to 0, and second, EV should be greater than or equal to Z1 by Z2. Now from the first condition we will get frequency of oscillation. Condition is Z1 plus Z2 plus Z3 equals to 0 at the frequency of oscillation. So when you substitute this, what will have? J omega L1 plus Z2 is J omega L2 and Z3 is 1 upon J omega C should be 0. So if I take J omega out, it will be L1 plus L2. This going on the other side, you will have minus 1 upon J omega C. Can say omega coming on this side, will have omega square equals to J square, this J and this J square, and this negative sign will go. So you are left with 1 upon L1 plus L2 into C. Now you know omega is 2 pi into F. So removing the square, you will get omega equals to 1 upon under root L1 plus L2 into C. Now omega is 2 pi F, so can say frequency of oscillation FO is nothing but 1 upon 2 pi into L1 plus L2 multiplied by C. So this is the first condition. According to the second condition, can say AV should be greater than or equal to Z1 by Z2. So what is Z1? J omega L1, and what is Z2? J omega L2. So it should be greater than L1 by L2. So your gain should be greater than L1 upon L2 in order to get sustained oscillations as per these two criteria. So these are the criteria for oscillation. Now how to substitute in the actual amplifier circuit? You can say the resistance, why this resistance RB is connected, it is necessary bias to transistor. In order to get necessary bias to transistor, we require RB. Then you have RE, the emitter resistance RE used for thermal stability. Then CE, it is used to prevent negative feedback through RE. Then you have CB, which is used for ripple rejection. Where is CB? You can say over here, to remove the ripple and also to reduce noise. Then you have RFC, that is radio frequency choke coil. It is used to avoid AC drop, across power supply and to prevent loading at feedback network. So these are the functions of the, can say, the power supply, then capacitors, why they are connected in the circuit. These are the functions for the same. Then you have L1 and L2, these inductors. Why we are using L1 and L2? These can be tapped coil or split coil. Similarly, you have L1, L2 and C network, which form a frequency selective network. As we have seen in the first slide, that is frequency selective network and feedback network. If RC is connected in the circuit, then it will act as load. You can see here, you don't have any RC connected over here. If it is connected, then it will act as load. Therefore, to avoid this, RFC is connected in place of RC, as it will act as open circuit at high frequency. For high frequency, this part will act as open circuit, right? This is all about Hartley oscillator. For further concepts, kindly keep watching In 5 Minutes. Thank you.